So after that, as you can see, I just wrote some points and tips related for Venturi Tube. As you can see, this item can be used for different types of fluids such as clean, slurry, or even etc. You are able to use it for gas service, air service, liquid. Even, for example, for medium viscosity and high viscosity, you can have Venturi Tube to be used in your services as well. But do not forget, for the case of fluid that you have some particles inside, the size and the dimension of those particles must be taken into consideration, because to some extent maybe those particles are in the really big size, so for sure the throat of the Venturi is going to be choked. So you have to actually bear in your mind that you need to check the dimension of the particles, based on the ppm from process department. After that, you can just see that the turn down ratio of it is 5 divided by 1. It can be actually increased up to 8 divided by 1 as well. Less permanent pressure loss. In previous sheets I just told you that the amount of PPL that could be generated here is just around 20% or 25% of the actual delta P, which is totally less than other types of differential pressure principles such as orifice plates and flow nozzle. You can just see that the accuracy of this one is plus and minus 1% of the full span, so it could be really reliable and to some extent acceptable as well. The upstream length of this device could be comprehended based on the diagram and the map that I just brought for you. You can just use this diagram to understand the amount of upstream based on the calculation of beta. After calculating beta ratio, you can just check this diagram to understand what size is suitable and appropriate for case of upstream. Let me just show an example for you. Just imagine before the Venturi I have a reducer. You can just see this one. So I should just pick the letter of A. A here is related for reducer, as you can see. And just imagine, for example, the beta is around I don't know, for example, 0.6. So can you see this one? This one is 0.6 related for beta, and you can see A here. So if I just point this one to the vertical arrow, I will understand it's something between 6 and 8. So for these types of things, it's better for you to just consider the biggest size. This one is between 6 and 8, so it's better for you to just consider 8. So 8 times greater than overall diameter of the pipe would be considered for case of upstream. Just imagine your size is around 10 inches. So for sure, after this reducer, you need to put 80 inches as a kind of distance for case of upstream to install the Venturi tube. As I mentioned that before here, the downstream is approximately around 3 times of D. So for the previous example, after Venturi, you need to put 30 inches distance, and after that, you are allowed to install and put another device after Venturi tube. So you can just use this diagram in your work. As you can just see, I just put some expander, I just put some elbows, and there are some different types of things such as valves related for gate valve, glove valve, and check valve. And the time that you have these types of items at your work, you can just consider the amount of upstream accordingly. So about the other things related for Venturi tube, I just gave you some other points here. The construction based on this table is usually fulfilled or performed. As you can see, we have 2 different types of Venturi based on its construction. The first one is cast and the second one is welded. The cast can be fabricated or can be produced by this size of 96 inches, while the welded one can be fabricated up to 120 inches as well. The beta ratio for these devices have been written here, just so you can see that. And I just told you that up to 8 inches, this device is usually constructed based on machinery fabrication. It means that, for example, by means of CNC or things like that, you are able to just construct this one. But for larger size, it could be cast or welded types, which I just mentioned that in aforementioned table. As I mentioned that before on the whiteboard, there are two different types of the Venturi. The first one is related for Venturi nozzle, which is one of the subsets of flow nozzle, and after that in the following sheets I will just discuss them too. And the second one is the classical form of it, which is named after Sir Herschel, who just invented and discovered this shape for Venturi. So next one is Venturi has less PPL, I mean permanent pressure loss, as compared to all the instruments based on differential pressure measurements. As you could remember in just previous sheet, I just put my finger on this advantage of Venturi, that the related PPL is really less than orifice and flow nozzle. So to clarify this matter more, I can just show you this diagram. You can just see that, for example, in beta around half, I mean 0.5, you have just around maybe 18% of loss, while for case of flow nozzle you have something around 65% loss, and as you can see even for orifice you have around 72 or 75% of loss related to permanent pressure loss of the devices. So it means that the flow nozzle has greater actually PPL as compared with Venturi, and less than orifice plate. So we can just consider flow nozzle based on PPL between Venturi and orifice. And for sure one of the most disadvantages of orifice is having or is to have more PPL in a line.